Hey everyone, welcome back to Cam Room 5. We're going to continue experimental chemistry, and in today's video we're going to be talking about qualitative chemical tests. So what are qualitative tests? Qualitative tests are the one where we are concerned with the chemical identity of the substance regardless of their amount or their volume or their moles. We are concerned with only the chemical nature of the substance. Now these tests could be for ions or for gases. When we're going to perform these qualitative tests, the first one that we do over here is the test for ions. And we know there are two kinds of ions. Cations, which are generally metallic ions, positive in nature, or these could be anions, which are non-metallic and negative in nature. We use aqueous sodium hydroxide or aqueous ammonia to confirm the presence of a specific cation. In the first step, we add few drops of aqueous sodium hydroxide to be followed by excess, or we could be adding few drops of aqueous ammonia followed by the excess. Anions are variable in nature, so we have a different set of tests for each anion over here. Now imagine you have 8 test tubes, each with a solution of a specific cation. These test tubes could be having calcium, maybe chromium, maybe iron 2+, maybe iron 3+. But there are only one cation in each test tube. Now the first thing you notice is the presence of colorless solutions in the first 4 test tubes. This indicates that a transition metal ion is likely to be absent over here, because transition metals make colored compounds, right? They're not colored. The later 4 test tubes have colored solutions in them, which means a transition metal ion could be present because transition metals make colored compounds. Now when we add aqueous sodium hydroxide, we're going to be making some specific observations based on each cation. We don't only add few drops of the sodium hydroxide, we add few drops to be followed by excess, which means 1 or 1.5 centimeter cube. We use a dropper to add few drops of sodium hydroxide in the first step. We can see that precipitates have been formed in almost all test tubes except for the one. The presence of white precipitates could indicate something which the presence of no precipitate does not. Now, white precipitates could mean calcium, aluminium, or zinc ions. Green precipitates could indicate chromium or iron 2+ ions. Brown precipitates and blue precipitates indicate Fe3+ and copper 2+. When we add excess of sodium hydroxide, only one kind of white precipitates remain insoluble, and these are the calcium precipitates. While if the white precipitates become soluble, it could be zinc or aluminium. One of the 2 green precipitates, which belongs to chromium, becomes soluble. So chromium green precipitates become soluble in excess, while the green precipitates of iron remain insoluble. What happens to the precipitates of iron 3+ and copper 2+? They also remain insoluble in excess of sodium hydroxide. Now, to confirm the first ion, we heat the first test tube, which did not give any precipitates. Ammonia will be evolved, which a litmus paper confirms. Now we're going to perform the test with aqueous ammonia. What are we going to observe? We're going to be observing a similar kind of precipitation as in sodium hydroxide. But this time with the excess, aluminium white precipitates will remain insoluble, and only zinc precipitates will dissolve, making a colorless solution. What differences are else over here? So we can see chromium precipitates did not dissolve. They dissolved in sodium hydroxide, but they did not over here, while copper makes a deep blue solution in aqueous ammonia. So these tests confirm the presence of specific cations. Let's talk about the chemical bases of these precipitates and their specific solubilities. Ammonium, calcium, aluminium, zinc, iron, chromium, and copper are the cations that we talked about. When we add aqueous sodium hydroxide. It produces an alkaline environment, so calcium makes calcium hydroxide, aluminium hydroxide, zinc, iron, chromium, and copper hydroxide are made. And these are the precipitates that you receive. The colors that you get in the precipitates belong to these chemical substances. The precipitates are actually the metal hydroxides which are insoluble. Now, if the precipitates are specific color, that has a different property of why they are colored, but their solubility is something else. Like iron has green or red-brown precipitates based on the oxidation state of iron. Chromium hydroxide is green, copper hydroxide is blue. When the precipitates are soluble in excess, it is because they can make a complex. Now what's a complex? A complex has another kind of bonding called dative bonding, not involved in our syllabus. Like aluminium, zinc, and chromium precipitates and aqueous sodium hydroxide were soluble, right? So those were complexes. And that happens only in the excess of sodium hydroxide. For ammonium ions, you remember when you add sodium hydroxide, it produces ammonia gas, which can be confirmed by a red litmus paper being turned into blue. So these are the chemical natures of the colors and the precipitates. Let's talk about the test for anions. Imagine you have 7 test tubes. One has carbonate, one has chloride, then bromide, iodide, nitrate, sulfate, and then you have sulfite. Let me write the names of these specific ions so we know what we're talking about. Carbonate, chloride, bromide, iodide, then NO3- is a nitrate, SO4 2- is a sulfate, and SO3 2- is sulfite. In order to confirm carbonate, we can add dilute hydrochloric acid, because then you're going to see effervescence of carbon dioxide. To confirm chloride, we add aqueous silver nitrate with nitric acid, and bromide and iodide have the same test. To confirm nitrate, we're going to be adding a piece of aluminium foil followed by dilute sodium hydroxide, and then we're going to heat it. We'll see what happens. To confirm sulfate, we add dilute barium nitrate and sometimes nitric acid as well. For sulfite, we add dilute hydrochloric acid, plus we heat it. What are the observations? For carbonate, nitrate, and sulfite, you will see effervescence, while chloride, bromide, and iodide have precipitates. In the test for carbonate, you see carbon dioxide gas. The chloride gives white precipitate of silver chloride, bromide gives cream precipitates of silver bromide, and iodide gives yellow precipitates of silver iodide. In nitrate, you will receive ammonia gas upon heating, which can be confirmed with a red litmus paper being turned into blue. And over here, in the case of sulfate, you will receive barium sulfate precipitates, while in sulfite, SO2 gas will be evolved, which will turn potassium manganate dipped litmus paper into a colorless, because it's going to decolorize the potassium manganate. So these are the specific tests for the anions. I hope the visual representation of each ion is helpful for us, and in the next video we're going to be solving some paper 4 questions to further reinforce our understanding. Stay tuned, guys.